Welcome to lesson 1.2, where we're going to be looking at what happens with negative bases, as well as changing powers from one base to another. So remember, the base is the bottom part of your power that's raised to the exponent. So the whole thing is the power, but this thing down here that I've drawn the square that's raised to the exponent, that's the base. So we're going to look at the difference between having a negative base and then having a negative power. So this first one here, this is a negative base because this is the part that is multiplied by itself 4 times. And so over on part B, this one is your negative base. But then without the brackets, when you just have it out front, this is saying that we have a negative power. So find out what 3 to the 4 is and then make it negative. Same with this one here. This means we have a negative power. So we're going to look at the difference between those two. For 1a, negative 3 in brackets, so that's the base to the 4, means it's going to be negative 3 times negative 3 times negative 3 times negative 3. So that gives us 1, 2, 3, 4 negatives, and 4 negatives makes it positive, and 3 times 3 times 3 times 3 is 81. Whereas if we have negative 3 to the 4, then the negative stays up front, and we just have 3 times 3 times 3 times 3 times 3. So the negative stays out front, and that's negative 81. So a negative power is going to always be negative. But the negative base, it's going to depend on how many negatives we have that get repeated. So if we look at negative 3 as a base to the 3, that's negative 3 times negative 3 times negative 3. 1, 2, 3 negatives makes a negative. 3 times 3 times 3 is 27. And negative 3 to the 3, negative out front, and then 3 times 3 times 3 equals negative 27. And so negative powers are always negative. I'm going to write this little note over here. Negative powers are always negative. That's sort of one rule. But then if we look at negative bases, negative base, final sign depends on the exponent. And what's it going to depend on is whether the exponent is even. So here it was 4. If we have an even number of negatives, our final answer will be positive. But if we have an odd number of negatives, so we had to multiply it 3 times here, our final answer would be negative. So that's going to be our rule. Oh, darn. I made a square instead of a box. Let's make a box. And so based on what we found out here, are the powers below negative or positive? Here we have an odd exponent because 99 is odd. So that means we have a negative base with an odd exponent. That means our final answer is going to be negative. For B, we have a positive base, so no matter what we do, it's going to be a positive final answer. Here we have a negative base, but we have an even exponent, so that means this answer is going to be positive. And here we're going to have to do this first. This part here is going to be positive, but then we have a negative out front, so the final answer here is going to be negative. So a positive base will always produce a positive result. Check. If the base is negative, this is that thing that I wrote in the boxes up above. We need to check the exponent. And if the exponent is even, then our answer will be positive. But if the exponent is odd, then our answer will be negative. Okay, that was the first part of this lesson. The second part is changing powers to have a common base. I'm going to zoom in on question 1. Sometimes we're going to have to change the base. And in this example, we have a base of 2, a base of 4, and a base of 8. I use this cheesy phrase that we're going to be looking for, powers in disguise. And by in disguise, I mean, is there any way we could write it as something else? Is there any way that I could write 4 as a power of 2? Is there any way that I could write 8 as a power of 2? So a little note over on this side, we know that 2 to the 1 equals 2, 2 to the power of 2, exponent 2 equals 4, 2 to the 3 equals 8. So yeah, we can rewrite 4 and 8 as powers of 2, and then they'll all be base 2, and then we can do our exponent rules. So the 2 to the 4 stays the same, times. I'm going to rewrite 4 as 2 to the 2, and then that's going to be to the 5. So 4 is 2 to the 2, and now that's all to the 5. 8 I can write as 2 to the 3, and that's going to be to the 4. So even though we started off and they weren't all the same base, some of them were base 2 in disguise. 4 was really 2 to the 2, 8 was really 2 to the 3. Now we're going to use the power of powers rule. That means we multiply these guys first. So up top, I'm going to have 2 to the 4 times 2 to the 10 over 2 to the 12. Up top, I'm going to add the exponents. So it's 2 to the 4 plus 10 over 2 to the 12. And you don't have to write it. You could have gone straight to 2 to the 14. 2 to the 14 over 2 to the 12. We're going to subtract these, and you don't have to write this step. And we'll get to a final answer of 2 to the 2. So for question 2, we're going to look and see if any of we've got a base 3, 9, and 27. We're going to see if any of these are really base 3s in disguise. So if we write down the powers of 3, 3 to the 1 equals 3. 3 to the 2 equals 3 times 3, which is 9. 3 to the 3 equals 3 times 3 times 3, which is 27. So yeah, we've got some stuff in disguise. So 3 to the 11 stays the same, times 27 is really 3 to the 3 to the power of 4. And this whole thing is going to be over 3 to the 2 to the 7. We're going to do the power of power rule for these. So up top we get 3 to the 11 times 3 to the 12. So we're going to be adding those over 3 to the 14. If I add 11 and 12, 11 and 12 gives me 23. So I get 3 to the 23 over 3 to the 14. And now if I subtract away 14, I get 9. So overall, I get 3 to the 9. So I did this one without showing the in-between steps, and that's fine. But here we're going to subtract the exponents. Add the exponents, add the exponents. And here we're going to subtract the exponents. So steps for changing to a common base. First, we're going to decide on what the correct base to use is. You must be able to write all, this is a key thing here, all the powers in your question using this base. Typically, it's going to be the smallest one, but not always the case. We're going to place brackets around our replaced powers. And then we're going to use the exponent laws. So we're going to go over 1, 2, 3, 4, 5 more of these. If you want, try it yourself and then see if you get the same answer as me. So I'm going to write down the powers of 2 again. 2 to the 1 equals 2, 2 to the 2 equals 4, 2 to the 3 equals 8. And then I've got them all good. So 2 to the 3 stays the same, times 4 is 2 squared, put it in brackets, to the 5, over 8 is 2 to the 3, and that's in brackets to the 2. So I'm going to do power of powers first. So I'm going to multiply those. So it's 2 to the 3 times 2 to the 10 over 2 to the 6. So that's 2 to the 13 over 2 to the 6. I'm going to subtract those exponents, so I get 2 to the 7. Question 4 is so much the same as the other one. I'm going to do it pretty quickly. So 3 to the 7 stays the same. 3 squared equals 9. 3 to the 3 equals 27. So it's going to be 3 to the 3 to the 4 over 3 squared squared. Power of powers on those, so I'll be timesing the exponents. So 3 to the 7 times 3 to the 12 over 3 to the 4 gives me 3 to the, I add them because I'm timesing the bases. So add those exponents, get 19. Now I'm dividing, so I subtract and I get 3 to the 15. Okay, this one's a little bit different. We've got 4, 8, and 16. And your first thought might be, hey, 16 is really 4 squared. I could just use a base 4. But there's no way to turn 4 into an 8. However, there's a smaller base that works. 2 squared equals 4. 2 to the 3 equals 8. 2 to the 4 equals 16. And the reason I went there, just to show in a little more detail, if I did 4s, 4 to the 1 equals 4. 4 to the 2 equals 16. There's no way to get an 8. And so that's why I went back to the 2s. So we're going to write this. 8 is really 2 to the 3. So 2 to the 3 in brackets to the 7. 16 is really 2 to the 4 in brackets raised to the 5. 4 is really 2 squared to the 12. I'm going to power of power all of these, so I'm going to multiply all of those. So I get 2 to the 21 times 2 to the 20 over 2 to the 24. I'm going to add up top because we're multiplying, so that's 41 over 24. And when I subtract that, I get 6 and 10 and 1 is 17, so 2 to the 17. Question 6. These look like they're all going to be base 5. So let's try that. 5, 1 is 5. 5, 2 is 25. 5, 3 is 125. 5 to the 4 is 625. Yep, it works. So we're going to replace them all. So 5 to the 19 stays the same. 25 is really 5 squared. Put it in brackets. Raised to the 17. All over 125 is 5 to the 3. Put it in brackets. Raised to the 5 times 625 is 5 to the 4 inside brackets squared. Power of powers for all of those, so I'll be multiplying them. So 5 to the 19 times 5 to the 34 over 5 to the 15 times 5 to the 8. So up top, 34 and 19 gives me 353. So 5 to the 53 over 15 plus 8 is 5 to the 23, which works out not so badly. When I subtract 23, I just get 30, and we're dividing, so we subtract, so the final answer is 5 to the 30. Question 7. Oh, I'm going to remember that up top here, when I had 4s and 8s, I couldn't write them as 4s, I wrote them as 2s. So I know that 2 squared is 4, and 2 to the 3 is 8. But what about the 49 and the 343? Well, neither of them they're not powers of 2, but they are. 49 makes me think of 7 times 7, which would be 7 squared. So let me try 7. 7 squared is 49. And on my calculator, 7 times 7 times 7, hey, it gives me 343. So I'm going to have it sort of in 2 separate parts. I'm going to have these guys as powers of 2, but then I'm going to have this as powers of 7, and I'm going to keep the 2s with the 2s and the 7s with the 7s. So 8 is really 2 to the 3, put it in brackets, to the power of 3 times. 49 is 7 squared, put it in brackets, raised to the power of 9, so it's 9. All over 4 is really 2 to the 2 squared times 343 is 7 to the 3, and that was to the 4. So power of power the heck out of this. We got this, 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 this. Each one of those pairs of exponents we're going to multiply. So that's 2 to the 9 times 7. 2 times 9 is 18, all over 2 to the 4 times 7 to the 12. We can only do exponent rules when the bases match. So the bases match here. Those are both base 2. And then the bases match here. Interesting shape. We'll try a rectangle again. So I'm going to use the division rule for the base 2 and then for the base 7. And the division rule would be subtract. So 2 to the 9 over 2 to the 4 is 2 to the 9 minus 4, which is 2 to the 5. And that's going to be multiplied by 7 to the 18 minus 12, which is 7 to the 6. So our final answer is going to be 2 to the 5 times 7 to the 6. And that's it for the lesson. We're going to be doing some of this classwork in class. Thanks for watching.